Two special cases of factoring are going to be discussed now in this short lesson. First of all, there are such things as perfect square trinomials. Now, if you remember, a trinomial refers to how many terms there are in the problem. And of course, there's three. So for instance, my example here, here's the first term, here's the second term, here's the third term. So this is called x squared minus plus 8x plus 16 is called a trinomial. Perfect square trinomials, things that are important to know about them. First of all, and most importantly, perfect square trinomials, the a, I should write that as lowercase, the a and the c values are perfect squares. So in your quadratic formula, ax squared plus bx plus c, the first and the last coefficient are going to be perfect squares. So if you notice in my first problem, the a value is 1 and the c value is 16. They are both perfect squares, so this is called a perfect square trinomial. Now, why is that important? That's important because when you factor a perfect square trinomial, both factors will be the same. And in this case, you get x plus 4 and x plus 4. A perfect square trinomial, both factors turn out to be exactly the same. Both factors are the same in a perfect square trinomial. And technically, I could write this as x plus 4 parentheses squared. And that would be the factors for that particular trinomial. Now, if you notice my second example, if you look at the a value, it's 9, and the c value, it's 4. Again, they are both perfect squares. So therefore, if I was to factor this, 9x squared is 3x times 3x. The last sign is plus. That means my signs are the same, and that's minus, which means these are both going to be minus. And the perfect square of 4 is 2. So therefore, here are my two factors for this perfect square trinomial. And again, I could rewrite that as 3x minus 2 parentheses and put a little square on the outside. So those are perfect square trinomials, and they're easy to spot because the a and c values are perfect squares. The second type of case is the difference of two squares. And what's important to note about the difference of two squares, it's exactly what it says. It's minus, and we've got two squares. But the most important feature is the b value is 0. This number right here is going to be a 0, which wipes out this term, and this symbol right here is going to be a minus. So these are all going to be in the form ax squared minus c. For instance, here is a difference of two squares problem, x squared minus 16. Also important to note that also in this case, the a and c values are also perfect squares. So if you notice, my a value is 1, my c value is 16. Now, when you factor these, the factors will be exactly the same with opposite signs. The factors are the same with opposite signs. So, x squared, that's x times x. We know 16 is 4 times 4, but the signs are going to be opposite. So you notice these factors are exactly the same, but the signs are opposite. So I have x plus 4 and x minus 4. Another type of example would be, I'll leave that written up here, I'll write on the left side. Let's say you have 9x squared minus 64. Very easy to factor because the factors are going to be the same with opposite signs. Well, 9x squared, that's 3x times 3x. The signs are opposite, and 64 is 8 times 8. So I put 8s there, and there are my factors for my difference of two squares. And that is how you recognize those and how you factor them. So two special cases, the perfect square trinomials and the difference of two squares, and that is how you handle both of those cases.